This time I want to talk about direct and inverse proportions. It is always appearing in the exam, so I think it's worthwhile to discuss this a little bit more. So this will be a summary, and then I'll also show the different kinds of questions that may appear, and it's worth taking note of. I'll go through the basic of direct proportion in this section. So what is direct proportion? We can look at stories like maybe we have people and biscuits. So people and biscuits. So I can name this as P, and then I can name this as B. So what happens is, if we have one person, maybe say person A, he can actually consume maybe say 5 biscuits. So one person can consume 5 biscuits. So when we have more people, say let's say we have 3 people, when one person can consume 5, that means 3 people will be able to consume 15 biscuits. So we see that when the number of people increase, the number of biscuit that gets consumed increase. So you get people and biscuits. More people equals to more biscuits. So the converse is also true. That means we have less people, then they will consume less biscuits. So the idea is like this. If you see that when you increase one, you increase the other one, and when you decrease one variable, then it becomes the other variable decrease, then we say that those two variables, in this case the people and the biscuits, are in direct proportion, like this. Then if we want to use a mathematical expression to represent this, then it will be representing as P equals to KB. Or if you see formulas and books, right, in textbook they will say that Y is equals to KX. This is usually the starting equation that we will work with when we are doing direct proportion. So this K is a constant. That means it can be any whole number or any fraction, as long as this number remains the same all the time. This is one of the more basic stuff. So when I have a question like this, they usually give you a table. Then the table contains X and Y or any other pair of variables, and they will ask you to determine whether the variables are in direct proportion to each other or not. So in this case, we know this equation. So Y equals to Kx, and K is a constant. So Y over X will be a constant. So when K is always the same, then we can say that Y is directly proportional to X. So that is the gist of it. We will make use of this table, and I will come up with a table, another row, which is Y over X. You can also use X over Y, and you will get a constant number as well if they are in direct proportion. So I use the calculator and find that this is 1.3, this is 1.3, and these two are the same. So then you can see that Y over X is equals to 1.3, or Y is equals to 1.3X. Then because Y over X is a constant here, then we can say that X and Y are in direct proportion. So based on the same logic, then question B, the method would be the same. If Y over X is a constant, then Y is directly proportional to X. Or if not, right, then it is not proportional. They are not directly proportional to each other. So we start with this again. We create Y over X. So we get 11 over 2 here, 11 over 2. This is 13 over 2, then like that. Because in this case, you see that not all the Y over X is a constant. So we can say, since Y over X is not a constant, then X and Y are not in direct proportion. So that's how you show it if you get a table like this. This is the one type of the question. This is another type. So they, instead of giving you a chart or a table, they give you an equation. Then with that equation, they will want you to decide whether it is directly proportional to each other or not. I mean x and y is directly proportional or not. We start with the equation given y equals to 3x. And you know that if x and y are in direct proportion, they will have this y equals to kx format. So let me write this on top. Side by side, you compare. So over here, you can see that y is over here. So these two are the same. They're related. They are corresponding to each other. Then you have x corresponding to x here. Then you have this and this. They are corresponding to each other. So that means y equals to 3x follows the y equals to kx format. So your y is to y, then your x is corresponding to x, and then you have k is corresponding to 3. Therefore, you can say that x and y are in direct proportion. Then we have another one here. We start with y equals to kx again. Then we have the equation y equals to 2x plus 1. If x and y are in direct proportion, then we would be able to map the corresponding variables values of y, k, and x. So in this case, these two can correspond to each other. This x corresponds to this. We can have k and 2, they correspond to each other. But you will see that there's this 1 that goes with no 1. It corresponds to no 1 in the y equals to k format. So if that's the case, right, then you cannot say, that means this y equals to 2x plus 1, this equation does not follow the format of y equals to kx. So then you would say that x and y are not in direct proportion. So this is the third one. You have y equals to kx again, and you have the equation given to us, which is y equals to 2x squared. So I write this. Let's find whether then x can go with x squared. Then k will correspond with 2. So in this case, right, then we have to ask, does capital X, right, correspond to small x? It doesn't, right? It doesn't. But it corresponds to x squared. So in that case, we will say that y and x are not in direct proportion. But there's a catch here, a special case, because we can name x squared as x, then y will be directly proportional to x squared. So if we were to answer the question, they say determine whether x and y are in direct proportion, then we will give the cher this answer. They did not ask for whether it's y and x squared are in direct proportion or not. So your answer will not be the second one that I talked about. So this is the third type of direct proportion question. It's still considered very basic. So they say that there are two variables that are in direct proportion. Then they ask you to identify what are the two quantities that are in direct proportion. So what we look at right now is the y equals to kx equation again, and then we try to compare it with whatever that is existing for us. Then we do the identification, say which unknowns, which variables will correspond to each other, so that they will have the y equals to kx format. So the y will go with the y square, then you have the x with the x square, and you have the k with the 60. So you say then x is x cubed, then the k is 16. Therefore, y squared is directly proportional to x cubed. So we use the same method on this. So I take the capital Y and the capital X here. Then I put the given equation, and then I try to link them up and see which unknowns are corresponding to each other. So we can see this, and this. So I try to show the circles with different colors so that you can see which one correspond to which one. So in this case, right, then Y will be corresponding to P, then the capital X is corresponding to Q minus 1 squared, then K is corresponding to 9. Therefore, P is directly proportional to Q minus 1 squared. So we have another one here. It it is similar to the one we have before, so it will follow the y equals to kx format. So we put the equations side by side. Then the equation that was given to us, it's p equals to 3 over q, and we can rewrite this as p equals to 3 times 1 over q. Then from then onwards, then we have to check which variables correspond to which one. So this looks like it's in the same position. Then this one and this one is in the same position. Then this one and this one is also corresponding to each other. So with that, you can say that the capital Y is P, then your capital X is 1 over Q, then your K would be 3. Then that means, right, P is directly proportional to 1 over Q. Like that. So in this case, the question is about whether the graph shape shows you that the two variables in the graph is directly proportional to each other or not. So back to a direct proportion equation, you have this. You can think of this equation as y equals to 3x, so where in this case k would be 3. So how you draw a graph like this is you draw y against x, and then you will become a straight line that cuts through the origin with a gradient of 3. So if you can have other values of k, and then they will also show you that the y equals to kx graph will be a straight line graph cutting through the origin. So if you have problems drawing y equals to kx, then that is part of another topic altogether. So in this case, we are supposed to look at the graph in A and determine whether y and x, they are in direct proportion or not. So you will see that we have y, x, and then we have a line, a straight line that cuts through the origin. So then, because this is similar to this, they follow the same criteria, having a straight line that cuts through the origin. So we can say that x and y are in direct proportion, like this. Then in a situation like this, so they say that we either have a y equals to direct proportion or inverse proportion, and neither. So let's briefly talk about a graph of an inverse graph. So in an inverse graph, later you will see that xy equals to k, or you can have a graph that is y equals to k over x. So which means you would have to draw y against x again. So that means you will draw a 1 over x graph, a reciprocal graph. So a reciprocal graph always looks like this. It is not a straight line, it's always a curve that looks like this. So in this case, right, your part B, right, is not an inverse proportion question because, or it's not an inverse proportion graph because it is not a curve and it's a straight line that goes downwards and it doesn't cut the origin. So it's neither direct proportion nor inverse proportion. So that means this is none of the above. So question 5 is our very standard beginner kind of direct proportion question. It's a basic question that makes use of y equals to kx. In this case, the question states this: the net force needed to push a block along the horizontal surface is directly proportional to the mass m. So we will start with an equation, say y equals to kx, but instead now we say that the force is directly proportional to mass. So we have F and M, and K is the constant. So we want to find the equation connecting F and M, and we are given these values. So when M equals to 5, F equals to 49, we will take these two numbers and then we substitute into the equation. So 49, our next line will be 49 is equals to K times 5, so K is 49 over 5. Then the equation, therefore it is F equals to K 49 over 5M. This is the equation that connects F and M. So then part 2, since we already have the equation, let me write down the equation again. F equals to 49 over 5m. We are now given the value of m. So when m equals to 14, we are supposed to find out what f is. So we will substitute m into this equation. So we will get 49 over 5 times 14. So this would give me 137.2 newtons. So do remember that there is units in the question. So if there is a need for units, please write it down. So it's 137.2. Back to this. So our third part, again, we will have to use our first equation, which is f equals to 49 over 5m. Then they say when m is 215.6, find m. So we will substitute this inside. So 215.6 is equals to 49 over 5 times m. So m would be equals to 215.6 divided by 49 over 5 gives me 22 kilograms. This is how we do it. Then let's go to the final part. The final part requires me to draw the graph of f against m. We know that it is like this. F is 49 over 5m. So f is directly proportional to m. So we can do f against m, and then we draw a straight line cutting through O. Then what we do is we can add in the values when m equals to 5, f is 49. Then you can have when m equals to 14, then the value up here, the graph would be 137.2. So it's just a sketch, so you can draw it like that. Or if you find that it's difficult to draw f equals to 4 over 49 over 5m, what you can do is you can come up with a graph, and then you just put in f values and m values. Then you choose values 1, okay, let's say 5, 10, 15, 20, and then you just plot the graph. That if not, you will just use your normal line sketching technique to draw this. I think it's fine if the teacher or the paper doesn't provide you with a graph paper. So the next question is similar, but you look at the question here. What you have to be very wary about is what is written in words. They say during a period of in the life of an earthworm, its length L is directly proportional to the square root of n. So it's not the same as y equals to kx, or you have to first write y equals to kx out, and then after that you do this. The length is directly proportional to the square root of n. So you alter the equation a bit based on what is given by the question in words. So then they tell you n is the number of hours and L is the length of the earthworm. 1 hour, okay, length of the earthworm is 2.5 centimeter. N is equals to 1 hour after the birth, like this. So with this, they say find the equation connecting L and M. So you will take this information given and then you put it inside to find K. So 2.5 is equals to K root of 1. So K is 2.5. Therefore, L is 2.5 square root of N. This is the equation that they want. So you will use this equation a lot for the rest of the questions, for the rest of the parts of these questions. So I will write it out again. So we know L is equals to 2.5 square root N. So they say find the length of the earthworm 4 hours after its birth. That means when N equals to 4, you have to find L. So L substitute. So L equals to 2.5 times square root 4 equals to 5. Length is in centimeters. Then the third part, actually, we will start with the equation again. So L is equals to 2.5 square root N. They say, how long does it take for the earthworm to grow to a length of 15 centimeters? So L equals to 15. What is N? So we will substitute 15 into the equation. So 15 is equals to 2.5 square root N. So square root n is 15 divided by 2.5 equals to 6. So n will be the square of 6. So you get 36. So this is 36 hours.